Hi guys, in this video we're going to revise linear equation. For example, what is linear equation, how many components in there and how to find those components, how to sketch a linear equation on Cartesian plane. Those are going to be the main contents of this video. So first, with linear equations, the basic form for linear equation is y equal mx plus c, with m is the gradient or the slope of the line and c is the y-intercept. The intercept is easy to find. For example, you have the Cartesian plane here and the line, the linear line is like this. Then this point is the y-intercept. Y-intercept is the point that the line cuts the y-axis. And how about the gradient? To find the gradient, so far we have learned two methods. The first one is rise over run, and the second one is this one. The first one you can obtain from graphs, and when you have the coordinate of 2 points, then you can use that. You can use this coordinate to find the gradient by using these formulas. So m equal y2 take away y1 over x2 take away x1. Now, we're going to do some example to remind ourselves about how to find the gradient from graphs and from points. With the first one here, so I have this graph and it's passing through two lines here. So I'm going to use the first method because I have graphs. I'm going to use the first method to find the gradient. First one, I'm going to write m equal rise over run. Rise over run. How can we find rise and how can we find run? So from the first point, you rise up, rise always go up, and then from here you're going to run to the second point. Okay, so this one is rise, this one is run. And you rise how many units? So here it's 3, and you rise up to 12. So it means you rise 9 units, positive 9 units. And then run, from here you run to this one. So from here x equals 0 and you run to 15. So it means you run 15 units. However, run can be positive or negative. It depends on the direction that you run. If you run from here to here, it means you're going toward the positive side. So your run going to be positive. If you run from here to here, then your direction is negative. So the unit that you run going to be negative. So in this case, because we run from here to here toward the positive side, so the value of run going to be positive. And your answer is 9 over 15. Easily here you can see the y-intercept is 3. Is the line cut the y-axis at 3. So y-intercept here is 3. Now I'm going to use the second method to find the gradient and see if it's exactly the same answer here or not. So m, with the second method, gradient equal y2 take away y1 over x2 take away x1. And y2 is the coordinate, you need 2 points, the coordinate of 2 points, and we have it here. So I'm going to choose, you're going to choose this one is 0.1, this one 0.2, or the other way round. I'm going to choose this one is 0.1. So it's going to be x1, y1, and this one is x2, y2. And then I'm going to substitute this value into this formula. I'm going to have y2 is 12, take away 3, and then 15, take away 0. So I'm going to have 9 over 15. So regardless the method that you use, they're going to give you the same answer. Let's check it out with the second example. The second example first, you're going to use m equal rise over run. And here, you rise from here, this point up, how many units? And then you run from here to here. So you rise up to here. So it means you rise from 2 to 7. You rise 5 units, positive 5 units. And you run from here to here. So it's going to be negative because you're going toward the negative side of the number line. So your run going to be negative direction, and you run from 4 to 1, so it means that you run negative 3 units. So your gradient now is rise 5 over negative 3, or you can write negative 5 over 3. The second method we're going to use is m equal y2 take away y1 over x2 take away x1. So you can choose, for example, this one going to be x1, y1, x2, y2. And then you substitute the values into this formula. I have y2 is 7, take away 2, and 1 take away 4. So it is negative 5 over 3. Sorry. It is negative 5 over 3. Exactly the same answer. Now, move on sketching linear equations on Cartesian planes. I made here 3 examples, but I already did these two examples because I don't want to make my video too long by going through 3 examples. So what you do, you're going to watch me doing this example, and then you do these 2 examples by yourself without looking at the videos, and then you can reopen the video to check your answer. Now, the first one, it is this one. So so far we've learned few methods to make to plot a linear equation in Cartesian plane, but here I'm gonna do a revision of 3 methods. They are table of values, gradient and y-intercept method, or x-intercept and y-intercept method. So the first one is table of values. What I do, I'm gonna make a very simple tables with x and y in there. And remember, for me, linear equation is a straight line. And a straight line, to draw a straight line, you just need 2 points only, and then you connect those 2 points together to make the line. So that's why in my table of values, I just choose 2 values of x only. So, and the value of x, it can be from negative 1,000, negative 5,000, or to 1, 2, 3, 4, 5. It can have any values. However, your space is limited, and then you don't have enough space to choose a big value of x. That's why I always choose small value of x in the table to make a table of values. So in here, I can choose, for example, x equal negative 1 and x equal 1. So if x equal negative 1, I substitute x value into here to find y. Y gonna equal negative 2 plus 1, so it's negative 1 here. And if x equal 1, then y equal 3. So now I have 2 points here and here. I'm gonna plot these 2 points in my Cartesian plane and connect those 2 points together to complete my graph. So it's negative 1 and negative 1. So negative 1 and negative 1 gonna be here. It's this one here, okay? And then next point is 1 and 3. 1 and 3 is gonna be here. And then I use the ruler, connect these 2 points together. Yeah, there you go. Because in my graph, in this Cartesian plane, I have 3 lines. That's why I'm gonna write the equation on top of each line or change the colors so you can notice which one belongs to which one. So this one is y equals 2x plus 1. Okay, I'm done. Now, I will check the other method, see if I have the same line or not. So with the second one, gradient and y-intercept, easily from here we know that the y-intercept is 1. So c equal 1. Y-intercept is 1. And the gradient, because the formula, our general formula is y equal mx plus c. So c is 1. And the gradient is the number in front of x. It's going to be 2. So gradient is 2. Or we can say 2 over 1. Why do I have to make it in 2 over 1 like this? Because gradient is rise over run. I want to find my rise and my run. Okay, so first thing with this gradient y-intercept method, you're going to plot the y-intercept, which is 1. So I'm going to plot it here, is 1. Look at this one. 1 here, and the gradient m equal 2 over 1, then it means you rise up 2 and run 1. So you rise up 2 and run 1, this point. So I have 2 points here, and they are exactly in the same, these 2 points exactly in the same this line. So if you connect these 2 points together, you connect these 2 points together, you will have exactly the same line, the pink line. All right, the last method, x-intercept and y-intercept. So x-intercept and y-intercept. X-intercept, we will have x-intercept when y equals 0. And y-intercept, you get it when x equals 0. So simply you just make look like a table of value x and y, and then you leave x-intercept, then y equals 0, and y-intercept x equals 0, and from here you find the value, the remaining value here. So if y equals 0 here, then x is going to be equal negative 1 over 2. And if x equals 0 here, then y equals 1. All right, then you have 2 points here, and you're going to plot these 2 points on the Cartesian plane. So the first one is negative 1/2. I'm going to choose different colors, like make it green. Negative 1/2 and 0, which is this one. This line, this point here. And then 0, 1. 0, 1 here. So you see? So the 2 points that we plot are this one and this one. Then if you connect these 2 points together, you're going to have exactly the same line, pink line. And the question is why I have 3 examples like this. You can see here, if you take a look carefully, you can see this one parallel with this one, and these 2 perpendicular with this one. So you can tell whether the lines are parallel or not by looking at the gradient. So you have 2 lines here. The blue line is y equal to x, take away 2, and the pink line is y equal to x plus 1. So once the gradient of 2 lines are the same, they will be parallel line. They will be parallel. And the gradient of this one is negative 1/2, and the gradient of those 2's are 2. So you can recognize that this gradient, negative 1/2 times 2 is equal negative 1, right? So negative 1/2 times 2 equal negative 1. So it means that when 2 gradients of 2 lines, the product of 2 gradients of 2 lines is equal negative 1, then those 2 lines are going to be perpendicular. Perpendicular is mean they meet at 90 degrees here. Okay, 90 degrees. They cut each other at 90 degrees. All good.